Up to this point, we've talked quite a lot about results, options, functions, structs, enums, and we've also talked about lifetimes in Rust. One of the other very important parts of learning about Rust are traits. We've come across a few traits up to this point, and whenever we talked about traits, I just mentioned, well, yeah, they're kind of like interfaces or protocols in Swift, for instance. Or you can also compare them with mixins in Dart. But I tried to jump over explaining exactly what they are. And we don't have to do that anymore, because in this part of the video, we're going to go into details about what traits are and what they're good for. Now, traits are shared functionality. So as I said, they're kind of like mixins in Dart, or like interfaces in other programming languages or protocols in Swift. So whenever, because most programming languages, they don't have like multiple inheritance, and in Dart, for instance, you can kind of achieve something similar to multiple inheritance by using mixins. And mixins is like a protocol in Swift where you can actually, you can do the same thing with Swift. You can kind of achieve multiple inheritance with Swift protocols as well. And going back to Rust's traits, there are shared functionality, and you can make sure that structs, for instance, or enums kind of implement that functionality. So you can bring a free type of functionality to your structs or enumerations. So don't worry if that sounds complicated. We're going to go into details about that in this section of the video. Now, we talked about debug traits, and I'll bring up this documentation that I've mentioned at the bottom of the screen. You can see it's a public trait debug, and it has some parameters and it has a result. So we've looked at creating like a person struct and then also deriving the debug trait from that struct. So we got that functionality for free, but just know that when you write this derive debug, at least what it's trying to do is trying to bring in some free functionality from the standard library into your code. We're not going to go too much into the details about that, but just know that debug is a trait that we've been using so far in some of our objects. Okay. Now, let's go ahead and start looking at some examples. So let's create a struct with first name, last name, and age in here. So let's say struct person. Okay, and we're going to say first name, string, and let's say last name, string, and age is a U8 or something like that. Okay. Now that you have that, let's go ahead and create an instance of this person. So let's say person is John Doe. This is fine. You can see it's a person with a first and last name and age of 30 in here, John Doe. Okay. Now, if you want to print, so let's go ahead and let me bring up this title. If you go ahead and try to print this instance of person as a debug value to the debug console, so let's say println, and we say we want to do a debug, so like this, and then put the person in here, you'll see that you will get an error in here saying person doesn't implement debug. The trait debug is not implemented for person. Okay, and it's actually suggesting us to add derive debug to that person. So let's go ahead and do what a Rust compiler says in here. So we say that we are going to derive a debug in here. Okay, and all of a sudden you'll see that our code is compiling fine, and then we can go to the terminal and see the message being printed somewhere. Let's see. Derive debug person has a derive implemented, but this is intentionally ignored during dead code analysis. Blah blah. Somewhere should that message be printed to the screen. Let's see. Print person. Person has a derived implemented. Age is never used this warning or origins in the derived micro debug. Person has a derived implementation. There's quite a lot of warnings in here. Here is the actual message being printed to the screen. Person first name and last name. Okay, so now that we've talked a little bit about the debug trait, that's not the actual most important thing that we're going to talk about. We're going to talk about our own traits, and those are the most important ones to discuss in this chapter. Okay, so we're going to go ahead and write a new trait. So a new trait is kind of like an interface. So we're creating now an interface called HasFullName, and this HasFullName expects any defining type or any implementing type to have a function called fullName. So let's create a trait and we say HasFullName. Okay, and in here let's see if the suggestion is good enough. Full name, self, string. Okay, so you can see it expects a method to be defined with a reference to self and a return value of type string. Okay, now let's go ahead and implement this HasFullName on our person. So by implementing a trait on an existing type, what you're saying is that you want person to conform to HasFullName, meaning that person all of a sudden should have an implementation for a full name function. So let's go ahead and say IMPL as an implementation HasFullName. I don't want to take that suggestion from GitHub Copilot because I think it's important that we implement this ourselves for person. Okay. So then what you need to do is to implement this full name function for your person. Okay. So let's go ahead and say fn full name in here, and we get a reference to self in here and return string. And then we're taking a format like this, and we say the first name and the last name, and then we say self first name, self last name. And there's quite a lot of curly brackets that need to be deleted. Okay, now you can see that Russ is quite happy about this. So it's saying that, okay, now you've implemented full name, which is a function that your trait required on person. And without that, the application wouldn't even compile. So if I comment this code out, you can see it says that we have to implement that function. I think actually you can get help from Visual Studio Code to implement that function. So implement missing members, and you can see it adds it here for you, but then you have to do the actual implementation yourself. So it just adds the function signatures for you inside the trait that you're trying to implement. Okay. Now, you can also have traits that allow you to create new instances of existing types. So this is just another example of a trait that you can create. So you can see that we have a trait called CanInitializeWithFullName. So let's say traits CanInitializeWithFullName. Okay. And in here, what we are going to do is to say that any type that uses this trait or implements this trait has to be able to call a specific function that this trait specifies in order to create a new instance of itself. And itself is specified in a trait using the self keyword with uppercase S, as it is in Swift, actually. So we say we have a new function, which is not a method, meaning that it doesn't operate on self, because there is no self at this point. We have to create an instance of it. So we say fn, and then we say new full name. We take a string slice, and we return an instance of ourself. Okay. Now, let's go ahead and implement this trait for person. So we say impl can initialize, and then we do that for person. Okay. Great stuff. And let's go ahead then and implement the function. So let's get this error from Visual Studio Code and say implement. So given a full name, we want to go ahead and basically return. So take the string and split it. And from there on, we're going to assign the first name and last name and then some sort of an age to that person. So there was a suggestion from GitHub Copilot in here. As you can see, it creates a vector. So it takes the full name, it splits it using a space, and then collects the results. We've already talked about iterators from previous chapters, so you know that this collect is actually turning a map of string slices into a vector of string slices for us, and it creates a person with that with this vector's first component turned into a string, vector's second component turned into a string, and the age of 0. We can turn this to 30 or something. Okay, so excuse me. Now that we've done that, we can go ahead and create a new instance of person using person new function. So you can see new, and then we pass John Doe. And then after doing that, we can say println. Let's remove this debug trait from here. And let's go ahead and in there and say println first name. First name is this. And then we say last name is this and age is this. And then we pass all those components in here. There we go. Okay. So that's our code. And let's have a look at the terminal. And we say first name is John, last name is Doe, and age is 30. So this is how you basically pass a string slice to a new function that was specified on a trait, which your person structure then implements. Okay. Now, another useful trait that you can implement for your structures or enums is the display trait. And this display trait comes from fmt display. You can see in the std module. So this display is quite useful, I would say, and you're going to now see how it works. So let's go ahead and use this, use std_fmt in here, as you can see, okay? And then we're going to go ahead and do an implementation of display for our person struct in here. So let's say impl fmt display for person. I actually like this suggestion by GitHub Copilot. What is happening in here is that you can see that the display trait that we're implementing on person brings with it this particular function. So even if GitHub Copilot didn't write this function for us, you can actually get help from Visual Studio Code in here to implement that function. To implement that function for us here. And then you would do the implementation with the right macro as it is specified in here. So you get a formatter, kind of like a println or format. And you basically take this formatter, which is kind of like your output, and then you put this string inside it with the first name and the last name and the age. So let's save this file. And yeah, that's saved as well. Fine. Okay. So now that you've done that, you can actually print an instance of your person to the console just using curly brackets. So let's go ahead, instead of doing this println, you can say println as a macro, and then the display formatter in here, and then you can just print your person fully to the console using the implementation of display. So you can see John Doe is 30 years old, which is what we specified inside the display implementation. You see, John Doe is 30 years old. Okay, so if you didn't have this implementation in here, then you would get an error right here saying person doesn't implement std_fmt display. So because this particular formatter is using the display trait. So now you've also seen an example of your basically implementing the display trait. I should have brought up this label at the bottom of the screen a little bit earlier, but now at least you know how it works. So you've seen debug now, you've seen how we can implement the display traits, and you've basically getting used now to writing traits and also implementing traits, okay? So the implementation of this display trait, to be honest with you, isn't that important because we haven't talked about this right macro and also formatters, and they're not so important for the entirety of this course, to be honest with you. But what is important is understanding that there is some sort of a trait that is required to be implemented on your custom types in order for you to be able to print instances of your custom objects to the terminal with this particular formatter. And before you can actually use a formatter in println, then you need to implement this display trait for your custom objects. And you can pause this video and have a look at this implementation, and you can also Google a little bit online how this write macro, for instance, works and what is a formatter and what is this particular result in FMT. Okay. Now, once you have traits, you may also be trying to use traits as parameters, because traits are kind of like data types. So any object that implements a specific trait has that trait as part of its data type signature. So you can see we have a function print full name and age, and it takes any object that implements this trait as a parameter. So let's go ahead and write that and say fn print full name and age, and then we want to take any object that implements this trait. So let's say value, and then we say impl has full name. Okay, so you can see in here we can't actually do this kind of code because a trait, as you can see, the error says trait objects must include the dyn keyword, but we're not going to do the dyn, we're going to do the implementation. So if you want to take in a parameter, if you have a parameter that is of a trait type, so you don't want to specify a person in here, because maybe you also have a structure that is called dog, and that dog also conforms to the HasFullName trait. So you don't want to have two functions that do the same thing, but one takes a person and the other one takes a dog or an animal. You can't just say, okay, I take any value that conforms to this particular trait. And this is how you would write that function signature. So now that you have that, you can go ahead and actually call it here and pass a reference to your person in here, and your application works without a problem. You can see the name is being printed to the console, okay? Now, you may also be working with trait bound syntaxes, because you saw that this was a little bit awkward to write. But what you can do is to change your function signature so that it uses something called a trait bound syntax. So it's kind of like a generic, and that generic type will conform to that particular trait. So let's go ahead and write this and say, we say print details. I think the function was supposed to be called print details. And then in here, you just open a generic in here and say, okay, this generic type has to conform to this particular trait. And as you can see, then you can say, just give me a reference to that object. So to me, at least, this is a lot cleaner to write, because you specify your trait as a generic, and then you take that trait in as a parameter instead of working with this IMPL. So I actually suggest that you do something similar to this, okay? Now, you can also conform to multiple traits and specify them as generic inbound traits. So let's say that we have a trait in here called can run, okay, as you can see at the bottom of the screen. So trait can run, and then it has a function which is called run, and then it takes self as a reference, and it has no return value. And let's implement that for person, IMPL can run for person, okay? And then let's take Visual Studio Code's help to implement this function for us, and then we don't do anything. Okay, in here. Great stuff. Now that we have that, let's say that we want to, in this print details function, actually take in any object that has conformance to both HasFullName and also conformance to the can run trait. How do we do that? It's very easy. You can just say can run with a plus in here. So you can see now you have access to full name in here, and also your value can run as well. Okay, so you have access to that. But if you remove this from here, then the function doesn't understand that the incoming value conforms to the can run trait, which is down here, and therefore cannot call the run function on it. You can see you'll get an error in here. Okay, good stuff. Now, once you have multiple, like when you have these trait bounds in here, if they become quite a few, like you have T in here that conforms to this, then you can have E that conforms to something else. This function signature gets quite complicated to look at. So sometimes what you want is to move these out of here. So you just say that I have T in here, which T could be anything. But at the end of your function declaration, you say where T is can run, HasFullName plus HasFullName plus can run. Okay, so you can see this function also works exactly the same way. But instead of writing your conformance to traits in here in the beginning of the function signature, you move them out and place them at the end of the function signature. So looking at the function, it looks a lot cleaner. Okay. Now, a trait bound results cannot mix multiple types, and we're not going to talk about that right now, but just know that if you have multiple traits that you want to mix into a result that your function returns, you can't just do something like this at the moment, but we actually might see an example of using something like that in the future. But I just wanted to mention that it's not so easy to do that right now, but there are ways of getting around doing that as well in Rust. But if you're curious about that, you can do some Googling as well. But since it's not so relevant to this part of the video, I'm not going to go into detail so much about that right now. Now, a trait can also be implemented on another trait. So since traits are just blocks of code, they can also be implemented on other blocks of code, which are traits. So this process is called binding a trait to another. So you can now we can see, for instance, if we create a trait called HasName, let's go ahead and create a trait in here called HasName. HasFullName we have, let's say trait HasName, okay? And in HasName, we have two functions. One is a first name and the other one is a last name function. So let's say fn first name and a reference to self and returns a string slice. And then we say last name as well. Okay, great stuff. Now let's go ahead and say that if any object that conforms, so we say if any object that we're working with already conforms to HasName, then we want that object to also automatically conform to a new trait that we're writing, which is called, I think, HasFullName. Okay, so given a first name and last name, we can always calculate a person's full name, for instance, or an animal's full name if animals have last names. So let's say trait HasFullName. Okay, and then we say were self is HasName. Okay, and let's take this implementation from GitHub Copilot. I think it's pretty nice. So let's put a curly bracket in there. Okay, the name HasFullName is defined multiple times. Okay, so it seems like HasFullName. Okay, I see. So let's remove that for now. Good. We have an error down here, but that's quite fine. We don't have to implement HasFullName, I believe, for a person. Okay, let's remove that. And we have another error in here, which we're going to fix soon. Okay, but have a look at this implementation. But what is happening in here is that we're basically saying that a trait called HasFullName is created, where this HasFullName exists as long as self conforms to HasName. So you're basically saying that as long as an object conforms to HasName, it also automatically conforms to a new trait called HasFullName. Okay. So once we've done that, we can actually let's remove that in here. Okay. So we can see in here we have we can have then a function full name like this, and we don't have to implement it right there, but we can actually specify that it has a full name function. So this is two different ways of doing it. So in the previous example in here, you saw that I actually implemented it as well. But what you could do is just you specify the function called full name on HasFullName, and then you can go ahead and implement it later. Okay, so let's go and do the implementation for HasFullName. So we say impl and we say t HasFullName, or t where t is HasName. Okay, so this is a little bit more awkward way of writing this kind of function, because you could have actually written the function implementation right there. But if you don't want to write the function implementation in the trait itself, so like some people don't want to do, you need to then go ahead and do an implementation of that trait for any object as long as that object conforms to HasName. So it's a little bit more awkward to write this type of syntax than doing the implementation itself in the HasFullName trait. Okay. Now we have a person struct already. So if we go back to our person struct, which has a first name and last name, we don't have to do so much more with it. But if you don't have that person struct, you can go ahead and do the first name and last name implementation for your person struct. Now let's go ahead and make sure that HasName is implemented for person. So let's go ahead and we see that CanRun is implemented for person, but I don't see HasName being implemented for person. So let's see impl HasName. I don't see it. So let's go and implement that for person. So we say implement HasName for person. Okay. And you can see that it's asking us to implement these two functions, because remember, person has a first name and last name property, or first name and last name properties, but it doesn't have the first name and last name methods. So that's why we have to turn our properties into methods in order to conform to HasName trait. Okay, so we've done that now. We have the first name and last name, and we've made sure that our person conforms to HasName. All right, so now that we've done that, let's go ahead and create an instance of our person. And I can see in here, we have person new. We're using the new function from before. Okay. Now, after creating an instance of person in here, we can go ahead and try to print the person's full name. So if you go in here and say person.fullName in here, let full name. Okay. And then we can println that to the output. Now, You may be asking, but how did person actually get a full name? Because we never implemented has full name for a person. And the reason this happened is that we already conformed to the has name for a person, which exports the first name and last name functions. And if you do the implementation of has full name, you can see that this has full name is by default bound to any object that already conforms to has name trait, meaning that has full name is a free trait that every has name trait bound object gets by default. So then we get access to the full name function in here. Okay. Now, traits and structs in Rust are very, very important for understanding the programming language. I would actually say extend that list to traits, structs, enums, and also lifetime specifiers are some of the most important concepts in Rust. So before I continue with this course, I really, really suggest that you sit down, maybe grab a cup of coffee or tea or something, and sit down and have a go yourself at traits and working with lifetimes and lifetime specifiers, enums, structures, and play a little bit with them. And if you have knowledge from other programming languages, just like JavaScript, Dart, Swift, whatever it is, bring that knowledge in to Rust for yourself and try to kind of like create new traits where in Dart you would create a mixin and see how that works. Try to create a Rust trait and play with lifetimes where in Swift you would work with protocols, for instance, and completely forget about lifetimes. So see if you can bring your knowledge from other programming languages into Rust and try to create some examples for yourself as well until the coin basically drops on how lifetimes work, how traits work, and structures and enums, which I think are a little bit less complicated than traits, let's say. So I hope you enjoyed this video as well. And as I said, just go and practice as much as you can, and I'll see you in the next video.